For question 5, I have some images that will help me explain the 5 steps of lipolysis. So first, there has to be an onset of exercise, which then releases hormones, and these hormones are fast and slow acting. So as you can see, in our bloodstream we have fast and slow acting enzyme or hormones that bind to this adipose site. This then activates HSL, which is hormone sensitive lipase. This lipase will then break up this triglyceride that's found in the adipose site. So as you can see, we have glycerol and then our fatty acid chains. So then these will be broken up and then moved into the bloodstream. Next is transportation. We have, so our free floating fatty acids will bind to albumin in the bloodstream, and albumin will carry the free floating fatty acids down the bloodstream, and eventually these free floating fatty acids will be picked up by sarcolemma fatty acid binding proteins and moved into the muscle. And albumins only carry about 7 fatty acids, and then about 50% of them will be moved into the muscle. So activation, as you can see, we have our free floating fatty acid plus a coenzyme A. This then creates a fatty acetyl coenzyme A using acetyl coenzyme synthase. Now for translocation, so as you can see, our fatty acetyl coenzyme A is in the cytosol and is moved to the mitochondria using carotene transferase. The last step is oxidation and beta oxidation. So as you can see here, we have our fatty acetyl coenzyme A, which is a 6-carbon molecule. This then is broken up by this beta oxidation. This then produces an acetyl coenzyme A, and then this 4-carbon fatty acid chain again, and then again is then broken up by using beta oxidation, and which creates 2 more acetyl coenzyme A molecules, which these are then transported to the Krebs cycle.